Welcome to this essential guide on blind SQL injection, a stealthy and dangerous form of attack that can compromise your databases without direct output. Unlike traditional SQL injection where results are visible, blind SQL injection forces attackers to infer information based on subtle application behaviors. Attackers send a series of true or false questions to the database, deducing answers by observing changes in HTTP responses, response times, or application behavior. This process involves finding entry points in an application's interface where user input is directly used in SQL queries, enabling unauthorized actions. There are primarily two main types of blind SQL injection: Boolean-based and time-based. In Boolean-based attacks, queries force a true or false condition, and the attacker observes how the application's content or behavior changes in response. Time-based blind SQLi relies on response delays. A crafted payload intentionally slows down the database when a condition is true, revealing the answer through timing. Other related types include error-based, which triggers database error messages, and out-of-band, which uses external network interactions to exfiltrate data. Blind SQL injection attacks can lead to severe consequences, including unauthorized access to sensitive data and complete site compromise. They can also reveal the structure of your database and confirm the possibility of other SQL injection types. To prevent these attacks, implement parameterized queries, ensuring user input cannot interfere with the SQL query structure. Strict input validation and sanitization are crucial to ensure all user-supplied data is safe and appropriate before processing. Deploy a Web Application Firewall, or WAF, to monitor and filter incoming traffic, blocking malicious SQL queries based on predefined rules. Apply the principle of least privilege access, granting users and accounts only the minimum permissions necessary to complete their tasks. Implement robust error handling to avoid exposing detailed database errors to end users, as this information can be exploited by attackers. Conduct regular security audits to identify and fix vulnerabilities promptly, keeping your database updated and secure. Runtime protection, such as intrusion detection systems, can prevent malicious payloads from being executed in real time. Detecting blind SQL injections can be challenging due to the lack of direct error warnings, unlike classic SQLi. However, monitoring logs, checking app behavior for unusual slowdowns, and using automated scanners or intrusion detection systems can help identify them. A notable historical example is the 2012 Ghost Shell University attack, where a hacker collective stole 36,000 personal records using SQL injection. Understanding and preventing blind SQL injection is vital for developers and IT professionals to safeguard sensitive data and maintain system integrity.